Hi everyone. Um, Hope y'all are doing well. Today we're gonna talk about measures of central tendency. And I'm sure most of y'all are familiar. Pretty much everybody's gonna be familiar with a lot of this stuff today. So hopefully this topic isn't too complex or too difficult to grasp. Because we talk about central tendencies, things that are describing what's typical, what's average, what's most likely to occur. Now there's three different measures for that. The mode, the mean, and perhaps what everybody's most familiar with is the mean, obviously. But in statistics, this stuff it might seem fairly simple and easy at this point, but later on, it's very important because a lot of statistics, especially advanced statistics and inferential statistics, most of those like regression models and negative binomial regression models and all these more in-depth statistical procedures that y'all probably read through in some of your articles. What they're looking at essentially is conditional means, conditional averages. So these are the basics that really underlie a lot of what we try and do. And we're looking at, if you look at statistics, and I know everybody's getting a lot of people are very apprehensive about statistics in general, but when you break it down, even the most advanced things, you're looking at means with certain conditions attached to it, and then looking at the variation around it, looking at how far or how wide that distribution is, and how far things deviate from that mean is generally what we're talking about. But today we're going to talk about some of the, just the basic concepts of what the means are, the central tendencies in general, and how to get there, and what they're useful for, and the three different measures. And the mode is perhaps the most simplistic. It's the most common, most likely, most frequent. It's a variable that occurs more often than other variables. So it is really just looks at one domain, one aspect, okay, and it's just looking at frequencies essentially, looking at the most likely or most common value to occur within a data set. Here's like a little quick example I just pulled off the internet. So you can quickly see that the mode here for pet ownership would be dogs, because it's the most likely, most common, and most frequently reported number. It's the greatest probability of occurring. Just thinking of examples like I don't know if anybody's been to like Las Vegas, or if y'all know the roulette table, or with the ball, what they put in there, and is that even roulette? And I think it's numbers one, well, the zero, the double zero, and then through 34, and then you see that bar on the side where they have all the previous numbers that appeared, and if you see the same number popping up like a half dozen times, well, that would be the mode, as opposed to other measures. Okay, but can be calculated at all levels of measurement as appropriate for nominal and purely ordinal measures. So this is a nominal level type of variable, right? It's not trying to rank order these things, or there's no, you're not counting how many dogs someone has. That is a ratio. You could have 0 dogs to, 10 dogs to 100 dogs, I guess, if you're a dog hoarder or whatever. Um, but here it's just a good description, and very fairly easy to look at when you're looking at a pie chart or a bar chart, and it's just a quick descriptive. In my mind, that's what it's good for, the mode. And it's the most frequent. An example I think your text gave when this would be relevant to you guys is perhaps the most frequent sentence imposed, say for possession of marijuana. If you were interested in seeing the types of sentences and comparing it from jurisdiction to jurisdiction, from say Dallas County to Harris County, or to New York, or Houston to New York, or and just superficially wanted to look what people were doing, if it was a fine or included probation, or people got put in jail for, say, having an ounce of marijuana, or further. And I know other factors have to be accounted for. Hopefully y'all are thinking the same way, but that's something, just on his face you can look at, you can see the mode and how those things work. Now within the mode, what makes it complex is it can be bimodal. It can have more than one mode in a particular data set. Here's another little example I pulled off the internet. So if you had test scores, you could have low test scores, people who didn't study for this example. You know, I'm assuming it's about 33 or in the 30s here, and that's people versus people who did study. You know, the second mode would be 90s. It's not necessarily accurate by any means as a central, you know, a measure of central tendency. It can be very misleading, is what I'm trying to get at. So. Some of the advantages of the mode: it's simple to determine. You can quickly identify the most frequent, the most common, you know, the most, the high, you know, most probabilistic event from occurring just by looking at it on its face, usually, depending on how large the data set is and what you're trying to do. And you can also use it for looking at nominal and you know, purely ordinal measures, and that's not necessarily true for the other measures of central tendency. Disadvantage: doesn't account for all or even most of the available information and distribution. It ignores information. It's just looking at one thing. It's just looking at the highest reported numbers. Now, understand this is a bimodal distribution, so there's two. Okay. Another example would be domestic violence and recidivism, right? That might be an important thing we're studying, obviously. And this is actually an example I took out of your book, I think, as well. If you had like 20 people, if you had a prior arrest and you wanted to see how many incidents of domestic violence they were involved in the year following their, you know, release, or after, you know, release from custody, release from prison, release from jail, or whatever, and see how many incidents occur within the next year. You know, if you get 20 of them indicating none, but you also have, you know, a couple people indicating 4 or 5 different incidences going forward, that's important information to know. But if you just look at the mode, since 0 might be the most common within that type of data set, you would neglect to know that information, if that makes sense. Hopefully that makes sense. All right, from there, the median. The median, here's the definition: score at the 50th percentile in a rank ordered distribution of scores. So half the values below the median and half the values are greater than the median. It's appropriate for interval and ratio levels of data. And here's the equation. So hopefully next slide is a little more relevant and a little more helpful. So this is actually another example of response times for what you would want to do ideally if you're trying to assess the mean. You need to put things in a rank order, and what that means is here you have different cases. They don't necessarily come in this order, right? So one case might be indicating a 15-minute response time. The second individual might be indicating a 6-minute response time. The idea is to rank order from lowest to highest, or highest to lowest, right? And then to determine the exact median. I mean the middle value, or the middle number, or where the center is, essentially, of the rank. This is the ranking, okay? So if you look at these, they call them ranks. They could be cases, like case number 1, 2, 3, 4, 5, 6, 7, or subject number 1, 2, 3, 4, 5, 6, 7, or whatever, as long as the scores correspond from that in that order, okay? In that rank order, right? Now here's the equation for it. N generally is used to annotate the number. N equals number, okay? The number within a data set, within the values that you're looking at, okay? And here, N equals 7, because we're looking at 7 different subjects, 7 different incidents, 7 different reports of, you know, response times, okay? And what we're doing is adding 1 and dividing by 2. A fairly simple equation. It's not too computationally intensive by any means. So you have 7, you add 1 onto it, you get 8 divided by 2, and that's 4. So here you have the 4th score, which is the median, okay? And as you can see, it's 50% exists above it and 50% exists below, because you got 3 numbers below it You got 3 numbers above it in the rank order, okay? And this is for odd values. So it's a little bit different when you have even values, because then you gotta do a little more math. You gotta do a little more computation to understand to achieve the exact median, okay? The median, the midpoint. So here's for even values. You got 1 through 8, pretty much the same example. Everything's been scored in ascending orders here. So we have 8 plus 1 is the same equation divided by 2. So you have 9 divided by 2 is 4.5. And it's the 4.5 score. So that's between here and here. Now, that's the rank, okay? And the median's between the 4th and 5th scores. So it's between 6 and 9. What you do there is add those two together, divided by 2, and 7.5 is your median for even values, okay? When your rank order is of even values, it's going to be between that, okay? And that's how you're going to do the computation for that, all right? So the advantages of the median, unlike the mode, there is just one median, all right? Because we can have bimodal things. There could be incidents, even in the previous example where there was multiple modes. But there's just one median. It's the exact middle of a rank ordered distribution. So if you look at the background here, if you think of the median like on a parkway or something like that, you know, and dividing lanes, it's the exact middle, right? It's not influenced by outliers so much, and that's important. Outliers are extreme scores, extreme cases. Right? If we wanted to study, you know, the average department size of, you know, of police agencies across the country based on cities, New York, that's an extreme outlier because there's, you know, tens of thousands of folks employed there. All right, or even if we looked inside the state of Texas at police agencies and determined how many was the department sizes and who they're hiring, or sheriff's departments, right? There's about, what, 256 counties in Texas, and, you know, Harris County and Dallas County and, you know, Bexar County or Bexar County, San Antonio folks, in Austin, Travis County. Those are kind of outliers. They're going to pull the average really far. But the rest of the 250 counties out there that don't have a million people in that city, you know, their departments are going to be relatively small, or you know, the sheriff's departments in those counties are going to, if one does even exist, they're going to be a lot smaller than those, you know, massive counties, and well, population-wise at least. Okay. Disadvantage, uses only 2 pieces of information. Now the mode is just one. Mode is just looking at the script. Now the median is just getting the midpoint, so it's not necessarily fully accurate. Okay. Now the mean, the arithmetic average of a group of scores. So the observations. Everybody knows what the mean is. It's the average. When you're talking about average, you sum up all the scores, then divide by the total number of scores. Now, your textbook kind of talks about the differences between the population mean and the sample mean. And they talk about annotation, which is important for you guys to know and have an understanding. So mu is generally annotated as the population mean, right? Now, for the sample, you'll see this X bar. And that's consistent pretty much across the board. The X bar is generally going to be a mean and recognized. So if you see an X bar equals in a number there, you know that's what the average is, okay? The arithmetic mean, okay? Or the arithmetic average, all right? So this is the summation sign. It really, this picture I got off the internet, it doesn't have the I here to annotate the number of cases. So I mean the number of observations. I mean the scores of the observations. So I'll get to that in a second though. But that's kind of simplistically how it is written out and detailed out. So everybody's, hopefully you're familiar with it, and we'll talk about it for a second real quick. So here's an example. So you got the values, even number values between 2, 4, 6, 8, and 10, right? I missed a comment there. But if you add these values up, and you get 30, and you divide it by 5 because there's 1, 2, 3, 4, 5. We added them all up together, which equals 30, and then we divide it by 5 because that's the number of cases, and that's 6. And our average, our x bar for that sample equals 6. All right, and that's a good score. It's good because we know, in this it's a normal distribution. I mean, y'all may or may not see that right now, but it is, and this would be the median in the mode as well. But the 6 itself, you can, from there, you can prove this. You can prove that it is actually the average. You can prove that it's the mean. All right, and you can do that by calculating the mean deviation scores of each value, which should all sum up to 0. So what do I mean by that? So if you slow it down and do it and think about it, the mean deviation, because that's what we're looking at, the mean and how far things deviate from that mean. So the score here is 2, right? And we know that the mean is 6. If we subtract it by it, we know that it's 4 away from the mean, right? As well as 4 is 2 away, -2, and then 8 is 2, and then 10 is 4. So if we sum all these differences up together, they should all come to 0. So 4 plus -2 is -6, plus 0 is 0, plus 6 is 0, right? And that's how you prove that the mean, all right? And that should always be true, and that's the mean deviation. And we're going to start talking about certainly within the next module, deviations, standard deviations, and how far things deviate from the mean, which is important for a variety of reasons, okay? Because you can kind of get a sense of how many outliers actually exist within it, how far they are, if it's too much, and those things are important, right? But nevertheless, taking a step back before I get too far off, the advantage of the mean, intuitive appeal, everybody knows about the average, uses all information within the data set. So it's great except for outliers, and it's the most precise. It takes every score into account. It factors all information we have and brings it all into one value, right? Disadvantage is outliers. Certain things can pull it. You can pull your average, right? If you know, I have 10 people in the class, and you know, I have two people score below a 20, and the rest of the class, 8 other people get 90s on the exam. The average score on his face would probably be in the 60s, right, or 70s, and then I might be freaking out. But those are outliers because they pull it. They pull it really far. It's like average household income, and that's why a common measure is the mean household or the median household income. Is because they try and get the central number, right? Or because certain people are going to make, you got the Bill Gateses out there making billions of dollars each year, but that's not representative of what the general population is making, because those types of numbers highly pull it. All right, Bill Gates is out here. The rest of the people in the world are probably closer here, and the median and the mode is the most often indicated. So last time, hopefully y'all watched that video. It was the last video on the last week's module with that with some lady and I put up there because I thought she explained it fairly well, talking about the differences between the distribution, because this is what we're looking at. Now, in a normal distribution, the mean, median, and mode are all going to equal the same, all right? They'll all be straight down the middle. There's no differences in the values. But that's not generally how life works, right? With everything we do. There's going to be a negative skew to the data or a positive skew to the data where the tail ends off, right? Examples for negatively skewed data would be, the scores in the class. So if we have 0 here to 100, the mode and median, most people are going to be up here in the 80s or perhaps 90s range here. In the mean, because some people might drop it and some people might fail out or whatever and just not do any of their work or skip all their exams, and that's going to pull the mean real far away. All right. similar to positively skewed data, where the tail extends far out to the right. This is often seen in like victimization data sets, or even in self-report delinquency data sets, where people are asked to respond to, how many cars have you broken into the last year? Well, most people are going to put 0 here, or 1 maybe, or smoke marijuana, or drink and drive or something like that. And then you might get a motor meeting here of a 1 or 2, but uh, there's going to be a few individuals that broke into 20 cars in the last year, and they're going to really pull it, and they're going to pull the average out, the mean out, in a positive direction. Okay, so hopefully this brings a lot of last week together and this week together, and these are good exercises. No, obviously the measures of central tendency are very important in going forward, especially it doesn't go away. As far as you go in statistics, really that's essentially what you're looking at is conditional means, conditional averages. And what I mean by that is there's going to be certain conditions attached to that average, okay, or certain conditions attached to that mean. And when you look in your regression models, your multiple regression, and hopefully I've read some articles, academic journal articles, and seen those things. But in some of those analysis that people do might seem overly complex, but at the end of the day, when you break the math down, really they're looking at just the means while accounting for other factors, essentially, and looking at the variation of that and saying whether it's within a significant level that we'd like to accept or not. So these are measures of central tendency. Hopefully they make sense. If they don't, always feel free to email me any questions, any concerns that y'all got. And hope y'all have a great day. All right.